So section 1.6, rationalising denominators. Now, what I'm going to do, I've just realised that in the last video, talked about section 1.5, and I'm going to talk here about how to do the questions, but we haven't really talked about surds and why it's important to simplify them. So I'll talk here about rationalising denominators, and then I'll do a separate video about surds and what the point of dealing with surds and simplifying surds is. So this word rational, you might have heard of rational numbers and irrational numbers. For the moment, the only thing that's important is that an irrational number is a surd. If you put it in a calculator, you're going to get a long decimal, not a nice, neat, recurring decimal. Actually, it would be an infinitely long decimal that never recurs, right? It's a really messy number, an irrational number. And the word, the rational part of it comes from the word ratio, okay? So a rational number is a number that can be written as a fraction, as a ratio between two whole numbers, and an irrational number is a number where you can't write it as a fraction. So there's no top number, bottom number that are both whole numbers to make the square root of 2 or the square root of 3, for example. Now, there's a whole, half an hour-long set of videos about rational numbers and irrational numbers and proving that irrational numbers exist and why they're such odd beasts. I'm going to save that for the moment. It's definitely something that's worth reading up on, but I'm sure you can find things elsewhere on YouTube, things like the square root of 2 is irrational, and proving that is a really interesting proof. If you haven't seen that, it's definitely worth looking up, but my purpose here in these videos is to try and help you with this particular book, these particular exercises, and it's a little bit more sort of utilitarian and less philosophical, so I'm going to restrain myself and we'll just talk about how to do these questions. But it's nice to know that idea of rationalising means writing the denominator without the surds, okay? And it doesn't mean rationalising in terms of being rational, it means rationalising in terms of writing it as nice whole numbers or fractions. Now, of course, if your denominator is a fraction, then you can turn the denominator into just a whole number, can't you? You know, if you have any old thing divided by 2/3, well, that is whatever your top was times by 3 divided by 2, right? Flip the second fraction upside down and times if you're dividing fractions. So when we say rationalising denominator, we should end up really with an integer as the denominator. So that's what we're trying to do. Why are we trying to do it? Well, if we've got to deal with these surds, if we've got to deal with these nasty numbers, let's at least get them out of the denominator. If we're dividing by a nasty number, if I'm dividing by 2, that's not too bad. If I'm dividing by 0.76, that's pretty horrible, right? Dividing by a nasty number, if the second number in my division is nasty, then that makes everything nasty. So let's not do that. Let's at least get the surds out of the denominator if we have to. And secondly, well, just to take the first example here, 1 over root 3 is the same as root 3 over 3. Those two things are the same. I'll do that as an example in a second. But which one are we using? I wouldn't accept 2 over 4 as an answer to a question because it's not in its simplified form. We need a standard way of writing any number, and we've decided that this is the standard way and this is not the standard way. Our standard way is going to involve rationalised denominators. So those are the two reasons why we'd like to do this. Let's have a look at how we do it then. So now, really important, there are only 2 tricks here. There are only 2 things you can do to rationalise the denominator. If those 2 tricks don't work, then you can't rationalise the denominator yet, okay? Both of the tricks involve the same thing. Let's go back to this one. I can't change this fraction. If I'm not going to change a fraction, then the trick is times by the same thing on the top and the bottom, okay? It's like cancelling up fractions, finding equivalent fractions, or if you like, root 3 over root 3 is 1, so I'm taking that fraction and timesing it by 1. I have to times by the same thing on top and the bottom. Both of the tricks that you can use involve times by the same thing on top and the bottom, okay? 1 times root 3 is root 3. Root 3 times root 3 is 3. So that's where I get my answer, okay? The next example they've picked, 1 over 3 plus root 2, is ready to be dealt with. And I'm going to use the difference of 2 squares trick. So if you've got 2 things added together on the bottom and one of them is a surd, use 3 minus root 2. Oh, 3 minus root 2. So I'm just changing that plus sign for a minus sign and having the same 2 terms there, okay? Now, one mistake that people make is that they times by that on the bottom but forget on the top. Now, I need to times by the same thing on the top, otherwise I'm changing the fraction, okay? So 1 times 3 minus root 2 is 3 minus root 2. On the bottom, I get 3 times 3, which is, I'm going to expand all the terms here. Once you've done this a few times, you can see the shortcut. 3 times 3 is 9. 3 times minus root 2 is minus 3 root 2. 3 times root 2 is 3 root 2. Positive times negative is a negative. Root 2 times root 2 is 2. So I end up with 3 minus root 2 over, well, that and that make 0. So 9 take away 2 is 7. Okay, so I'm actually using difference of 2 squares here. It's 3 squared is 9. Root 2 squared is 2. 9 take away 2, and that's 7. So when you've done that a few times, my strong advice is do it this way by actually expanding out every term there into 4 terms. When you've done it 6 or 7 times, you'll see the pattern and you can start making shortcuts. If you don't put the practice in, you'll mess that up. You'll end up doing some things like 3 times 3 equals 3 and root 2 times root 2 equals 4, right? You'll make those mistakes. So to avoid that, put the practice in, get used to it by actually expanding out these bottom terms, and then go for the shortcut when you've done 6 or 7 or maybe 16 or 17, you know, however many it takes for you to see that that's an obvious step. Now, you have to use those two tricks. So if you look at D here, D is not ready to be dealt with. If it was 1 over 1 minus root 3, then that would be fine. We'd do 1 plus root 3 on the top, we'd do 1 plus root 3 on the bottom, and we'd times by those things, but it's not. It's 1 over 1 minus root 3, and it's got a squared at the bottom. So we're going to have to simplify before we can apply the pattern there, okay? So let's look through the exercise. These ones, question 2, they're all ready to be dealt with. Here, times on the top and the bottom by 1 minus root 3. Here, times the top and the bottom by 2 minus root 5. Here, times top and bottom by 3 plus root 7. Here, times top and bottom by 41 plus root 29, okay? These ones here are there separately at the moment to show you, look, before you can deal with this, it's not of the form that we want. The denominator is not one term take away another, and it's not one term added to another. It's something else. So first we need to simplify these before we can do anything. So to go back to the one from the example, the way we can simplify this is expanding the brackets out on the bottom. So that is 1, well, I really will spell out the stages here. You can always fast forward it, can't you? So 1 times 1 is 1, 1 times minus root 3, 1 times minus root 3, so that's minus 2 root 3. Negative times negative is a positive, root 3 times root 3 is 3, so 1 over 4 minus 2 root 3. Now the bottom is 2 terms, one take away another. So now it's ready for me to apply this on the bottom. I've got to do the same on the top. And I'm going to times this fraction by this on the top and this on the bottom, and then I can simplify it. I'm not going to go through the details of that. They're in the blue box on page 14 for you when you are ready for them. Now that is how to do everything on chapter 1. I'll do an extra video just talking a little bit about surds and why it matters.